Good morning, boys and girls. Right, what I taught in last class, in yesterday class we had discussion on properties of carboxylic acids, physical properties and chemical properties. So continuation of carboxylic acid chemical properties. Today we are going to discuss decarboxylation reactions and few addition reactions with respect to C double bond O. So right, today I am going to finish this topic. Right, in last class, so where we ended, reaction with C double bond O, no? Right, so it means nucleophilic additions. Right, second type, no? Third type, right. So third type, right, let me once again give same reaction. Reaction due to chemical reactions due to C double bond O in carboxylic group. So this is what nucleophilic addition. Another you can call it as nucleophilic addition. Nucleophilic addition in carboxylic acids. So here best reaction is reduction. So reduction of carboxylic acids with a strong reducing agent like lithium aluminum hydride. So it will give alcohols. So in last class already I gave same reaction. When this carboxylic acid treated with lithium aluminum hydride, so it will use what alcohol or CH2OH. So here aluminum will give what this lithium aluminum hydride will produce H minus. So here hydride ion is the nucleophile. So here which is the nucleophile in this? Hydride ion. So hydride ion is the nucleophile followed by hydrolysis. Followed by hydrolysis you will get what carboxylic acid converted into alcohol. So always primary alcohols, you will get what? Primary alcohols. So reduction of carboxylic acids and aldehydes, always you will get primary alcohols with lithium aluminum hydride. This is what we had in last class. Right, continuation, let me give one more reaction. The same carboxylic acid when treated with excess lithium, alkyl lithium. So alkyl lithium also powerful reducing agent and followed by hydrolysis. This one also gives primary alcohol. This RLI also very powerful reducing agent like lithium aluminum hydride. So here what you will get here actually, sorry. So actually here, so what is the product here? Mainly here you will get what? If you take it a limited amount of RLI, you will get what? Ketones. If you take excess, then finally you will get what? Third degree alcohol. So let me give the mechanism. Here if you take it limited means what? 1:1 ratio. Limited, if you take it ketones you will get. Let me explain the mechanism of this reaction. If you see the mechanism of this reaction, here we have carboxylic acid. This is RCOOH. So when RLI, here who is the nucleophile? R minus is the nucleophile. So R minus is a nucleophile. So this nucleophile will attack on what? Carbon and sorry. This nucleophile, right? This nucleophile R minus attack at carbon. So resultant what will get here? R CO minus. This lithium will attack on oxygen. Then you will get OLi and here R and OH. Then after hydrolysis you will get what? Here H plus and OH minus. So H plus, here O minus and lithium plus. Lithium plus will combine with OH minus and H plus will be attacked on O minus. Resultant what you will get? You will get a dihydroxy compound. So here on same carbon you will have two OH groups. So whenever same carbon having two OH groups, then it will be unstable. So it will be unstable due to what? Steric repulsions on means due to lone pair on the oxygen. Here carbon is what? Small atom. So on small atoms, when you arrange four groups tetrahedrally, even though, so here there are lone pairs due to what? Lone pair and bond pair, lone pair repulsion. So there will be a loss of water from two OH groups. Then after loss of water, what will you get here? R C double bond O, R you will get it. This is what final product. When you take the limited amount R 1:1 ratio of this carboxylic acid and RLI. If you take excess, then what will happen? If you take excess, If you take excess, then again one more mole of that what R minus L plus. Okay. So this R minus again react with carbon and this Li will attack on oxygen. Then followed by hydrolysis. Finally, what will get? Third degree alcohol you will get it. Third degree alcohol you will get. This is what with excess amount. So if there is a limited amount RLI means you will get ketones. If you take excess amount of RLI, so final product is third degree alcohol. And here limited, if you take it here limited means you will get ketones. With limited amount you will get what? Ketone. With excess, so you will get what? Finally third degree alcohols. These two are nucleophilic addition of carboxylic acids. Right. Next continuation of chemical properties. What is fourth type? Reactions with carboxylic group. So reactions with carboxylic groups. Reaction with carboxylic group. So the COOH group. So here this is what another you can call it as decarboxylation. Decarboxylation. Loss of carbon dioxide is said to be decarboxylation. So what will get decarboxylation on decarboxylation? Decarboxylation of carboxylic acid will produce what? Alkyl means alkanes. Alkanes, you will get alkanes. So if you see that one reaction is what? Soda lime reaction. So with soda lime reagent, what is the soda lime? It is there in the preparation of benzene from benzoic acid. So if you take soda lime, that what this is what carboxylic acid. Soda lime is a what mixture of NaOH, sodium hydroxide and calcium oxide. So you have to take excess amount of sodium hydroxide and calcium oxide. This when you treat it with soda lime and followed by heating NaOH and plus calcium oxide on heating, then you will get what? There will be decarboxylation. Then resultant what will get here? So RH you will get plus here carbon dioxide. This carbon dioxide is acid. So here who is base here? Calcium oxide and sodium hydroxide. So here both are base, but here NaOH is strong base. So this carbon dioxide react with NaOH. The resultant what will get here? NaOH byproduct. These are the what? Byproducts. Carbon dioxide 2 moles. Then it will use what? Sodium carbonate. Sodium carbonate plus water you will get. So what is the use of this calcium oxide in this reaction? What is the use of calcium oxide in this reaction? Here sodium hydroxide, what is the role of sodium hydroxide? To remove carbon dioxide. So to remove carbon dioxide we are using sodium hydroxide. Then what is the role of calcium oxide? So calcium oxide is a dehydrating agent. If there is any moisture in this reaction vessel or in this with this compound, then this moisture will be absorbed through calcium oxide. So calcium oxide is a very good dehydrating compound, calcium chloride, calcium oxide. So then this calcium oxide will remove the moisture if there is any moisture. But here this NaOH role is what? It will eliminate carbon dioxide. So once you release, once on heating, so once you get the carbon dioxide, then this carbon dioxide will be reacted with NaOH, then it converted into sodium carbonate plus water. So here what is the main role of this calcium means? This is what? A dehydrating agent. Dehydrating agent. If there is any moisture in this reaction vessel with this reactant, then so it will remove. Okay. If there is a moisture, then so what? There are what side reactions. So to avoid that, otherwise if you have the moisture, then what will get it here? Carbon dioxide react with moisture, then you will get the carbonic acid. Okay. So again it will be liquid. To separate this gas is very difficult. That's why here it acts as a dehydrating agent, and this role is what? To remove carbon dioxide. Okay. This is what soda lime. In place of R group, you can substitute n number of examples. Here R is alkyl means you will get alkyl. If R is aromatic means you will get aromatic ring. So by changing R group, you can get n number of examples in organic chemistry. Okay. This is what soda lime reaction. So if you have the best example known reaction, if you take it a benzene, so it is there in the preparation of benzene. Benzoic acid when treated with soda lime, so what you will get? You will get benzene. This is what known reaction. This is what here H. This H will combine with what here? Then carbon dioxide will be eliminated. You will get what? Benzene. This is what the best known reaction. Right. In place of R, if you put it aromatic, you will get corresponding aromatic hydrocarbon. So if you take it alkyl, any aliphatic, you will get corresponding aliphatic compound. Okay. So this is what basic reaction. This is one decarboxylation reaction. Next, this is one soda lime with soda lime. Next, decarboxylation. I think you had discussion in the preparation of alkanes. So how will get alkanes from the carboxylic acid? What is the reaction? What is the name reaction? Preparation of alkanes from carboxylic acids. Cool base electrolysis. So salts of carboxylic acid. Okay, cool base electrolysis. Cool base electrolysis. In this cool base electrolysis, you need to take salt of carboxylic acid, sodium or potassium salt. So like sodium or potassium salt, you can take sodium or potassium, you can take it O minus K plus. You need to dissolve in water, you will get aqueous solution. So right now this aqueous solution, is it electrolyte or not? So electrolyte means it should give the ions. You need to get the free ions, cation and anion. It should be electrolyte. Once you get the electrolyte means cation and anion in the aqueous medium, then only you can do the electrolysis reaction. If you are not get any ions, there is no electrolysis process. It means to carry charge, you need to have the ions or electrons. Okay, electronic conductance is what? Electricity, and this what ion conductance is what? Electrolytic conductance. Means that is what electrochemistry, that we will discuss. Right. Let me explain this what cool base electrolysis of carboxylic acid salt, sodium or potassium. You can take it. Let me take any one salt. This is what sodium salt of carboxylic acid. This is aqueous. Aqueous means there will be a water also. Let me take separately water. Right now we are passing what? This is H plus and OH minus. Now we are passing current. We are passing current from the external battery. Then what will happen? Then there will be electrolysis at the corresponding electrodes. So at anode there will be oxidation, at cathode there will be a reduction. So resultant, what will you get here? Right. So here here normally means you will get here 2 moles you have to take it. Then you will get R and R plus carbon dioxide plus you will get what? H2 gas plus NaOH. So these are all gases. This H2 gas and this CO2 also gas. Here you can take it alkanes like ethane, butane. You will get what? Even number of hydrocarbons. From this cool base electrolysis, you can prepare only even number of hydrocarbons. You cannot prepare methane. You cannot prepare methane from this electrolysis. Okay. Right. Here R is, you can take it any alkane. Right. If you see the mechanism, so let me explain the mechanism. So what means where you will get carbon dioxide and hydrogen, and this what means alkane. This R means alkane. Where you will get alkane? These two you will get it what? At anode. At anode you will get. At anode these two products you will get. This H2 you will get at cathode. Cathode. Let me explain the mechanism how this electrolysis will take place in the reaction vessel. It is very important. So many times JE also many times asked questions based on this electrolysis. So we do the electrolysis of any salt of carboxylic acid. What are the products at anode and what are the products at cathode? It is very important. So sodium hydroxide will be in the reaction vessel. Right. If you see the mechanism, of reaction mechanism, first let me explain at anode. At anode. So anode means what will happen at anode? Always oxidation. So at anode oxidation will take place. Oxidation will take place. Here we will undergo oxidation, carboxylate ion. So if you take the carboxylate, this is what carboxylate ion is, an anion. So this anion will undergo oxidation. Oxidation means what? Loss of electrons. When it is losing electron, then you will get what? Here there are 3 pair of electrons in oxygen minus. Whenever O minus is there, there are 3 pairs with 1 bond. So now what will get here? Only 5 electrons. Then so 1 electron will be removed. Then if you take 2 moles, how many electrons I will get? I will get 2 electrons. 2 mole of electrons. If you take 2 mole of carboxylate salt, you will get what? 2 mole of electron. This is what, after getting this, this is what? Radical. This is carboxylate radical. So this is what? Carboxylate anion. This is carboxylate radical. So this carboxylate radical, further it will undergo homolytic cleavage. Homolytic cleavage. So homolytic cleavage means half arrow, fish hook arrow. The resultant what will get among? Here you will get what? R radical plus carbon dioxide will be released. This odd electron combined with odd electron of carbon, then you will get what? Carbon dioxide, double bond. Then you will get carbon dioxide, then this is R radical. Here 2 moles means 2 R radicals are there, then these 2 R radicals will combine, they will form alkane. There will be a bond formation between carbon and carbon. In this Kolbe electrolysis, there will be a CC bond formation between R group and R group. So here how many moles of carbon dioxide you will get here? 2 moles of carbon dioxide and 1 mole of, this is alkane. Alkane, this is carbon dioxide. These are the two products you will get at anode. Next, if you see the reaction at cathode. So cathode, what will you get at cathode? Cathode means what here? Oxidation means at cathode reduction should takes place. If you see the reaction at cathode, reduction will take place. We will undergo reduction. Right here, let me explain one thing. Here, how many anions totally? How many cations? In this, when this salt put it in water, you will get two type of anions. One is carboxylate anion, another one is OH minus anion. And cations, what are the cations? Na plus cation and H plus cation. Now, whenever you have the two ions in the electrolytic solution, when you are passing current, then there will be a competition to get discharge. So that time, so you need to see the potential orders. So when it is undergo oxidation means you need to see the oxidation potential. Oxidation potential of carboxylate ion is more than OH minus. So that's why this carboxylate ion will undergo oxidation instead of OH minus. Next, in Na plus and H plus, who will undergo reduction? Na plus and H plus, which reduction potential is more? Hydrogen reduction potential is 0. Sodium plus reduction potential is minus. So minus is more or 0 is more? 0 is more. That means hydrogen means H plus will undergo reduction. Right? Instead of Na plus and H plus, here H plus will undergo reduction 2 mole. You are taking here 2 mole means here water also you have to take 2 moles. So then you will get 2 moles of H plus ion, let us assume here. Then it will take 2 electron, then you will get what? H2 gas. So 1 mole of H2 gas. Where you will get 1 mole of H2 gas? At cathode. At cathode. So what are the remaining things? What are the remaining things? Na plus and OH minus are the remaining things. The remaining is what? This is NaOH. Will be in the reaction vessel. So you can collect your alkane and you can remove this what? Carbon dioxide. Here if you take the reaction balancing, so 1 mole of alkane you will get 2 mole of carbon dioxide and 1 mole of H2, and here 2 mole of NaOH. This is what reaction. When you take the 2 mole, you need to pass how many faradays of current to get this product? You need to get how many? You need to pass how many faradays of current, electric charge? When you take 2 moles, it is there in the electrochemistry, no? To get 1 mole of electron, you need to pass 1 Faraday. So here you are getting 2 mole of electron, means to get 2 mole of electron means you need to pass 2 Faradays. So when you do the electrolysis of 2 moles of this carboxylate salt, you need to pass 2 Faraday current. Then with that you can expect the numericals. So if I pass 2 Faraday current, then so what amount of alkane you will get? 1 mole of alkane you will get it, and 2 moles of carbon dioxide you will get at STP, and 1 mole of H2 you will get it. So if they ask in competitive point of view, if I pass 2 Faraday current, then here ratio of these two gases. So what is the ratio of volume ratio here? 2:1 at STP. So what you will get here? 2 mole means at STP what? 1 mole of any gas will occupy 22.4 liter. 2 into 22.4 liter, and here 2 into 2.4 liter of H2. 2:1 ratio you will get it. That means here 44.8 liters, and here 22.4 liter of H2 will be released. So this is what, based on this you can expect the numericals, okay, with electrochemistry and organic reaction. So this is what at cathode there will be reduction, at anode there will be oxidation. So if you pass 2 Faraday current, this is what amount of alkane you will get it. So if I pass only 1 Faraday, then so what you will get here? Half mole of 1 mole here you have to take here half mole of alkane and 1 mole of carbon dioxide, half mole of H2. So this is what according to mole concept you will get the products. So this is what general decarboxylation of coal-based electrolysis. If I give the applications, means examples, real examples. If you take it acetic acid, if you take the salt of acetic acid, sodium acetate, 2 moles, when you aqueous, when you pass current, electrolysis, what will you get product normally? Ethane. Ethane is the product, plus 2 mole of carbon dioxide and 1 mole of H2 and NaOH is the product. This is what ethane. So to prepare ethane, you need to take this one acetate. salt of acetate you have to take it to prepare ethane. So if you want to prepare propane, propane means what you have to take it to get propane means, so what you have salt, mixed salt you have to take it to get like Woods reaction, like Woods reaction only here you will get the products. Okay, if you want to get propane, so getting propane is very difficult, pure propane. So here acetate ion and another one is what propanoids, propanoid you can take it. Okay, then R combined with R, that is what side product. So getting odd number of hydrocarbons is very difficult from this. You will get mixture of products you will get it, but pure getting odd number of hydrocarbon is very difficult. From this method methane cannot prepare, you cannot prepare methane from this method. So you can prepare only even number of hydrocarbons, purely you can prepare. If you want to prepare odd number means it is very difficult, you will get the mixture of products. Okay, so this is what sodium acetate, like this you can take it. If I take dicarboxylic acid, what will you get, Amma? So here I have what COO salt, COO potassium salt. If you do the electrolysis, here what will you get products? Here what will you get product? What will you get products? Amma? So here what will you get product here? You will get radical. This is a radical mechanism. So here after elimination of CO2, here radical, both radical will combine. You will get cyclohexene, not dimerization. Okay, cyclohexene is the product. So when you take the dicarboxylic acid, salt of this, you will get cyclohexene. Let me ask one more question. Dicarboxylic acid. Here if you take this cyclobutene dicarboxylic acid, right? If I do the electrolysis of this compound, so what I will get product here? Can you guess it? What product you will get it? Amma? What product you will get here? What is the product? Butadiene or any other product? So if you write it butadiene, so it will be wrong. Okay, so butadiene. So if you write butadiene, so it will be wrong. So here you will get what? Dimer. So dimer, you will get it dimer. Why it is dimer? So here after elimination of carbon dioxide, here radical you will get, here radical you will get. So 2 mole of this will combine with other 2 mole means there will be a dimerization like R plus R. So like this you will get. This is what product you will get it, not this one. Why you are not getting this? This compound is what? Anti-aromatic. Getting anti-aromatic product is less stable. Always you need to think with stability. Okay, in chemistry, anti-aromatic compounds are highly unstable. So getting this product is unstable, but getting this product is stable. That's why it will undergo dimerization, but not butadiene. So it's very, very important. Okay, this is what anti-aromatic. This is what anti-aromatic, not anti. Right, anti-aromatic compounds are highly unstable. So that's why here dimerization will takes place. Okay, this is what you can think it. This is what coal-based electrolysis reaction. Next, heating. So decarboxylation with heating. Next, heating reactions. On heating, there will be a loss of carbon dioxide. Heating means thermal reaction. So heating means thermal reactions. So let me take in this heating of beta keto carboxylic acids. Beta keto carboxylic acids. Carboxylic acid. It is there in JEE Advanced, but not there in NCERT. So heating of beta keto carboxylic acids. Let me take one example of beta keto carboxylic acid. This is what R CO and CH2 and COOH. This is what with respect to functional group. This is a functional group. With respect to functional group, this is alpha position. This is beta position. Okay. So what are alpha, beta? Then next gamma. Next delta. Next epsilon. Next running no. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma. Okay, like that. There are Greek Latin words like ABCD. there are Greek letters from alpha to omega, from alpha to omega. So, but mostly we will take up to 3 carbons, alpha, beta, gamma, sometimes delta, that is it. Maximum 4 carbon only we have. Okay. So, alpha, beta. So, this is what beta keto. So, when beta keto on heating, this beta keto compound. So, here whenever you heat beta keto compound, then there will be a loss of carbon dioxide. Then what will get product here? R, CO, CH2, this H will combine to CH2. Then what will get? All means ketone you will get, or CO, R you will get. Always on heating of beta keto carboxylic acids, products are what? Ketones. Products are ketones. So, this what you can take it, this is thermal reaction. Let me explain the mechanism. This is thermal reaction. So, here R, you can take here, this is what? CO, R, CH2, and here COOH. COOH. So, here what will happen? So, there will be cleavage. So, cleavage means what? Homolytic cleavage. Here also there will be a bond. So, this is what? O and OH. So, here there will be a homolytic cleavage. Homolytic cleavage. So, after this homolytic cleavage, this carboxylic group converted to CO2 and this hydrogen combine with this CH2. The resultant what will get? So, R, CO, CH2 will get, or this hydrogen, there are 2 chances, this hydrogen can combine with this oxygen or CH2. If it is combined with this oxygen, then what will happen here? So, what will happen here? You will get what? Here double bond. Here you will get double bond. If this is polar bond means here O, and this is what polar type means partially negative and partially positive. So, then here hydrogen if attack here, double bond you will get. Double bond means when sp2 carbon having OH group, then it will undergo tautomerization. After tautomerization also you will get same product, R, CO, CH, here CH3, right, R, CO, CH3 only will get it. This is what just thermal means you will get the what radical type of homolytic cleavage type of mechanism. Okay, this is what always one thing you need to remember, heating of beta keto carboxylic acids. So, always products are ketones. Products are ketones. Same way, let me take one more example. A beta keto. Okay, let me give the example, real example like now tell me here if I take a cyclic compound, this is what we have COH, then on heating what will get product here? This is what alpha position, with respect to this one, this is alpha position, this is beta position. On heating what will get? There will be loss of carbon dioxide, then what will get product here? You will get what? C double bond O, cyclohexanone. Cyclohexanone is the product. So, you will get cyclohexanone is the product, there will be loss of carbon dioxide. Next, let me ask one question, this question asked in previous JE. We have this is what is the name of this compound? What is the name of this compound? No, I am not asking, just general name, not IUPAC name. So, general name. This is pyro compound or bicyclo compound? This is a bicyclo compound, right. So, with respect to bicyclo compound, this is what with respect to functional group here, this is alpha carbon, this is what? Beta carbon. So, on heating, so what will get here product normally? Amma? What will get product? So, normally what will get here? Keto you will expect keto, but here there is no reaction. Why? Because what is the reason here? At bridged carbon, this is what? Bridged carbon. So, at bridged carbon getting that what any carbanion or carbocation or radical is very difficult. Why? Because if you get the carbocation or radical, then it will disturb its geometry, means its shape of this bicyclo compound. So, always you need to remember that bridged carbon, this is a bridged carbon, alpha carbon is the bridged carbon. So, getting radical bridged carbon is unstable. So, that is why this compound cannot undergo loss of carbon dioxide. So, loss of carbon, even SN1 reaction also or SN2 reaction also. So, whenever you have here halogen, not this double bond, if you have the halogen here, So third degree halide. So whether it will undergo SN1 reaction or not means it will not undergo any SN1 reaction. Why? Because you will get carbocation. Once you get the carbocation, then you will get planar structure. Once it get planar, then the structure will collapse. So that's why here getting radical or carbocation or carbanion. So it's very difficult. That's why this type of compound cannot undergo any reaction whenever you have here substituent. Here even decarboxylation also will not takes place. Here no reaction, you have to give the answer. So no reaction. This is what decarboxylation of beta keto carboxylic acids. Next, other reactions. So on heating, this is A and B. Heating of carboxylic acids with I think you might have studied in carbonyl compounds preparation. Okay, reheating of these carboxylic acids with manganese oxide at 573 Kelvin. So what will get products normally? If I have this what formic acid, if I take formic acid, so 2 moles of formic acid on heating with this manganese oxide at 573 Kelvin temperature, what will happen? So there will be a loss of that what carbon dioxide and water, you will get what formaldehyde. You will get formaldehyde is the product. Here there are two, dehydration and decarboxylation. Both will take place. Dehydration as well as decarboxylation. Both will take place. Then you will get what carbonyl compound. Heating of carboxylic acid in presence of manganese oxide at this temperature. So always you will get products, carbonyl compounds. This is what example 1. And if you take example 2, if you take acetic acid, what will you get, Amma? Acetic acid, on heating of acetic acid, what is the product? Right, very good, acetone. So acetone is the product. So here what, this is what decarboxylation, and this is what loss of water. Then CH3 radical combined with C double bond O. Then what will you get? CH3, C double bond O, CH3. You will get acetone. You will get acetone is the product. So on heating, you will get what carbonyl compounds. This is what heating. Next, normal strong heating, and next heating of calcium salts. Heating of calcium salt. Heating of calcium salts, carboxylate salts. So what will you get here? I think it is there in the preparation of cycloalkanes. Cycloalkanes is there in JEE advanced point of view, but it is not there in NCERT. So heating of calcium salts. So normally what will you get here? Heating of calcium salt. Right. If I have that word calcium formate, this is what calcium formate, minus calcium is the plus. On heating, what will you get? So there will be a formation of calcium carbonate. So calcium carbonate means you need to remove that what calcium carbonate. Then this hydrogen will be attached to C double bond O. Then what will you get? Formaldehyde. So formaldehyde is the product. Next, if I take acetaldehyde, the salt of acetic acid, calcium salt of acetic acid means calcium acetate. On heating of calcium acetate, what will you get product? Acetone. You will get what? Acetone. There will be loss of calcium carbonate. So like this you can remove calcium carbonate. Then what you will get? CH3 will be attached to C double bond O. You will get acetone. You will get what? Acetone. If you take the mixed salts, so what you will get here? Means calcium formate and calcium acetate. So what is the product? Major product. You give major product. Heating salt of calcium formate and calcium acetate. If you take it both salts, let me take it COO. This is what calcium formate plus calcium acetate. What will you get a product here? That what heating? This mixed salt. You will get what? Mixed products. You will get mixed product. So on heating of alone this compound, what will get here? Formaldehyde. So heating of this compound alone, you will get acetaldehyde. So now we have mixed. Mixed means you will get what? Acetaldehyde. So then there are totally possible products. What are the possible products? Formaldehyde is one product, and next one is what? Acetone. Next one is what? Acetaldehyde. So in this, among these, which one is major? Getting acetaldehyde is the major product. Why acetaldehyde is major? It is a crossed product. From this you will get hydrogen, from this you will get CH3CO. So then there will be a crossed product. So getting crossed product is the major one. So you will get three type of carbonyl compounds. In this, acetaldehyde is the major. This is what mixing of mixed salts. Next, if you take the salts of dicarboxylate, salts of dicarboxylic acids, salts of dicarboxylic acids, salts of dicarboxylic acid like adipic acid. What do you get? Carboxylic acid, adipic acid. So what will get amides? Heating of salts of dicarboxylic acids. Adipic acid means there are how many carbons? Adipic acid. So totally how many carbons? 6, no? Oh my, such a good apple. Okay, so in that you will get 6 carbons. This is what salt means. You have to take it as calcium plus 2. On heating, then you need to remove that what calcium carbonate. Then what you will get? What is the ring size? Inside ring there are how many carbons? Here 6 carbons. 1 carbon will be eliminated in the form of carbonates. Then 5 carbons will be remaining. So 5 carbon means what will get? Cyclopentanone. This is what preparation of cycloalkanones. Cycloalkanone. This is what cyclopentanone. Cyclopentanone. So to prepare cyclopentanone, you need to take it so salt of calcium adipates. This name is calcium adipates. Adipic acid means adipates. Calcium adipate, if you take it on heating, so you will get what? Cyclopentanone. Pentanone, you will get it. Cyclopentanone is the product. So to get cyclohexanone, so what you have to take it? Calcium pimelate. Calcium pimelate. You have to take it calcium pimelate. So on heating of calcium pimelate, so you will get what? Cyclohexanone. Cyclohexanone. So heating of what? Heating of minus heating of this is calcium pimelate. Calcium pimelate on heating you will get what? Cyclohexanone. So after getting cyclohexanone or cyclopentanone, so when treated with what? Any reducing agent like Wolff-Kishner reduction or Clemmensen reduction, if you do that, then what will you get here? What is the Clemmensen reduction? ZnHCl, HCl. Okay, then you will get what? Cycloalkane, you will get it. Cycloalkane. So reduction of carbonyl compounds. Clemmensen reduction, Wolff-Kishner reduction. So you will get what? Alkane. Then this is what here cyclohexane you will get. So here when you treated with Clemmensen reduction or Wolff-Kishner reduction, you will get cyclopentane. This is what cyclohexane and this is pentane. This is what preparation of many times asked in JEE. Okay. So from the salts of calcium dicarboxylic salts. Okay. These are what heating reactions, dicarboxylic acids. Next, few more. Right. Next, heating of malonic acid. We have one specific oxide. Next, heating of malonic acid. What is the malonic acid? Malonic acid. Malonic acid. Malonic acid is what? Dicarboxylate acid. In between two COH groups, this is what heating of malonic acid. So there are two possibilities. If you heat with phosphorus pentoxide is a very good dehydrating agent. It is not a decarboxylating agent, it is a dehydrating agent. So when you treat it with phosphorus pentoxide, then dehydration will take place. If you write the how dehydration will take place, let me write the structure. This is what carbon H, here what OH, and here double bond, and here OH and double bond. COH, CH2, COH. So when treated with phosphorus pentoxide, there will be a loss of water. It is not a decarboxylation reagent, it is a dehydrating reagent. It is not a decarboxylating reagent, it is a dehydrating reagent. So when heated with a P2O5, this malonic acid will give what? So what will you get here? Double bond you will get, here double bond you will get. Then what is the name of this product? What is the name of this product? When there will be loss of water, what will you get? Anhydride, malonic anhydride. So it is a carbon suboxide. This is what? Carbon suboxide. Carbon suboxide. Suboxide. So carbon will form how many type of oxides? Carbon will form how many types of oxides? 3 type of oxides. One is carbon monoxide, another one is carbon dioxide, another one is carbon suboxide. These are the 3 oxides of carbon. Okay, when how you will get this carbon suboxide? On heating of malonic acid with the P2O5. So this is what? Only dehydration. There will be a loss of 2 mole of water. So 2 mole of water you will get it. Next, same malonic acid. If you take it same malonic acid, if you heated with just heating at approximate 450 degrees Celsius, 450 degrees Celsius, what will you get? So there will be a loss of carbon dioxide, only one carbon dioxide. Then what will you get? Product acetic acid. You will get acetic acid. So without this P2O5 heating will give what? Acetic acid and carbon dioxide. In presence of P2O5 heating it will give the carbon suboxide. So carbon suboxide is a third oxide. Carbon will form only 3 oxides. One is carbon monoxide, carbon dioxide, another one is carbon suboxide. So in this 3 carbons and 2 oxygen, formula is C3O2. Okay. So this is what heating of carboxylic acids. This is what carboxylic acids heating, and in that there are fewer like dehydrating reactions and fewer decarboxylation reactions. Okay. So this is what decarboxylation of carboxylic acids. Next, I think 2013 JEE one question let me ask based on this decarboxylation. So JEE 2013, so there was one question, right? Let me give question. Right, in this find number of carboxylic acids. The number of carboxylic so that we have this what reactant. Here conditions will be given. First condition is what? Acetic hydrolysis. Second condition is here double bond. Second condition is what? Ozonolysis followed by hydrolysis. Right here on heating, hydrolysis followed by heating. So right now my question is, you will get what here? Product. In this you need to find a number of carboxylic groups. There are how many number of carboxylic groups are present in the resultant product? Just you think and tell. How many amma? 3. One answer is 3. What about other answers? Any other answers? Girl side. Just do trial and error. You know the concept, but molecule is little big, that's it. In JEE Advanced, there are big molecules, but concept will be very easy. So totally how many carboxylic acid you will get in the resultant product? So firstly what you have to do? You have to do the acidic hydrolysis. If you do the acid hydrolysis, then what will happen? This anhydride will open up. Then you what you will get here? Carboxylic acid. You will get both carboxylic acid. So hydrolysis of what? Anhydride in acidic medium. So then what will get amma? What will you get? So totally 4. Right. First let me explain. Here this side double bond, O, and this is anhydride. This is what? Anhydride. Right. When this anhydride undergo acid hydrolysis, then what will you get here? this what carboxylic acid you will get. This what this is keto group, and here you will get COH, and here also you will get COH. So when anhydride undergo hydrolysis, then you will get what dicarboxylic 2 carbon, means this is a ring, means you will get 2 COH groups. If it is open means open anhydride, then you will get only 2 moles of 1 dicarboxylic acid you will get it. So this is what dicarboxylic acid. In this first step, this is what product. But what you have to do here? You have to do heating also. You have to do heating also. After hydrolysis, you have to do heating. So when you do the heating, then what is the nature of this compound with respect to carboxylic group? With respect to this is alpha, this is a beta, no? This is alpha carbon. Okay. Distance. Right. This is what carboxylic group, no? With respect to this one alpha carbon, this is a beta carbon. Now this is a beta keto carboxylic acid, no? So what will happen on heating of beta keto carboxylic acid? There will be a loss of carbon dioxide. Now there will be a loss of these two, this one also alpha and this one are beta. So now there are 2 beta keto compounds. Then on heating, both the carbon dioxide will be, this what carboxylic acids will be removed then in the form of carbon dioxide. Then what will you get, Amma? In first step, what will you get first step? In first step, what will you get? This compound will get it in the first step. Then next second step, so ozonolysis. Whenever you do the ozonolysis, then wherever you have the double bond, you will get what? Without zinc, what will you get products? Carboxylic acids. So here there will be ozonolysis. These 2 carbons convert into what? 2 carbons convert into what? Carboxylic acids. So without zinc, you will get what? Alkenes convert into carboxylic acids. With zinc, alkenes convert into carbonyl compounds. So now in this final product, this is what final product A. In this there are how many carboxylic groups? So 2. So now answer is 2. Amma? Where, which double bond? This won't affect it. Why means on heating you will get the alkene only there. Again you will get alkene only. So acid hydrolysis means you are talking about what? When alkene undergo acid hydrolysis, normally what you will get? Alcohols you will get, no? So but again you are heating, no? Where is heating? Alright. Here again you are heating. So heating means what? Again alcohol converted to alkene only. Again same alkene only you will get, no? Here after hydrolysis, what, Amma? You will get this product, no? Up to this clear. Amma? Only one time. Not like that. So you cannot take it 1 mole. So whenever you have the anhydride, so this anhydride converted to carboxylic acid, then there will be a chance to get here also. Both will get hydration. But after getting this, you are heating, no? Whenever you are heating, then again here alkene you will get alkene. So again here, for example, after hydrolysis, what you get? This chance is there, no? Why? Because acidic medium is there will be electrophile H plus ion, then it will undergo electrophilic addition. By that you will get alcohol only, no? This only you will get. So this is the product you will get it. But our intention is final product, no? So again, second step, what you are doing? You are heating. Whenever you are heating this beta carbon, this will be eliminated carbon dioxide. Then again this will be eliminated in the form of water. Then again you will get alkene only, no? This alkene only you will get. So after this you have to apply second condition. In the second condition, only alkene converted into what? Carboxylic acid. Okay, right. So I did not give this, but no need to take. Finally, he asked what? Final product. In the final product, there are how many carboxylic groups? So answer is 2. So answer is 2. Not you cannot take it 1 mole of water, 2 mole of water. So whenever we do the hydrolysis, we will take n number of water molecules. It is very difficult to take 1 water molecule to do this hydrolysis of this group only. It is very difficult practically. Okay, on heating again you will get alkene only. Okay, right. So answer is what? 2 carboxylic groups you will get it. This is what answer. Right, next. Good question. Right. Next, other reactions like these are the main reactions with functional group, COH functional group. Next, some other reactions like HVZ reaction. okay, reaction with alpha hydrogen. Next one is fifth type, reaction with alpha hydrogen, with alpha hydrogens, alpha hydrogen of this is what CH, this is what alpha hydrogen, this is alpha hydrogen, this is alpha carbon. If carboxylic acid contains having this alpha hydrogen, then there will be reaction. That name reaction is said to be HVZ reaction, Hell-Holland-Zilkinski reaction. So this reaction name is, anotherly you can call it as Hell-Holland-Zilkinski reaction. Zilkinski reaction, very big name. HVZ reaction, simply you can call it as HVZ reaction. This is what HVZ reaction. So in this HVZ reaction, what will happen? Just you need to substitute halogen at alpha carbon. So when this any carboxylic acid, if it is having alpha hydrogen, when treated with what this X2, means X2 like chlorine or bromine, you can take it. But in NCERT, I think you have bromine with red phosphorus. When bromine treated with red phosphorus, then there will be a halogenation at alpha carbon. Then you will get what byproduct is what HBr. So one of bromine will be substituted at alpha position. Then product is what CHBr and COH. This is what alpha bromo carboxylic acid. Alpha bromo, this carboxylic acid is the resultant product. If you have the acetic acid, then alpha bromo acetic acid. If you have the propanoic acid, then alpha bromo propanoic acid. Like that you will get it. Okay. This is what HVZ reaction. HVZ reaction means you have to do the alpha halogenation at alpha position. You have to do it. Let me take some real examples like CH3CH2 and COH. When treated with Br2, you can take chlorine also, chlorine or bromine, anyone you can take, but not iodine. So Br2 and Cl2 in presence of red phosphorus. So what will get product here? CH3, CH, here Br and COH. So actually most of the reactions are very comfort with bromine. So compared to other halogens. Why? Because bromine and carbon electronegativity approximate similar. So it will be a good covalent resultant, you will get covalent compound. Okay, that's why most of the organic reactions, whenever you study the mechanism or reaction, so you will take it bromine as a main halogen compared to other. Later you can take the chlorine, but not fluorine and iodine. So this is what alpha bromination. So if you take any cyclic compound like what will get here, if you have this is a carboxylic acid, when you treat it with this reagent, where you will get bromination? Here, this is alpha carbon. Here there will be one hydrogen. So then you will get what this type of substitution. Okay. So like this is what HVZ reaction, nothing, just mug up. Okay, you need to remember this name. With this name, this is what condition. So whenever there will be halogenation in presence of red phosphorus, definitely there will be a substitution at alpha position. Okay, for that, so which cannot undergo HVZ reaction, which acid cannot undergo HVZ reaction, which is not having alpha hydrogen, like formic acid, benzoic acid. Okay, so like this. Okay, which is a carboxylic acid not having alpha hydrogen, then you cannot apply this reaction. This is what HVZ reaction. Next reactions with aromatic ring. In case of aromatic carboxylic acids, so let me take next. This is what sixth type. You can if there is aromatic ring, then only you can apply this reaction. Write down reaction of aromatic ring. Aromatic ring. So when there will be aromatic ring, then what will get? When there is aromatic ring means what is the name of compound? What would be the compound? Benzoic acid. You can take best example to get aromatic substitution. You can take benzoic acid. When we have the benzoic acid, there are possibilities ortho, meta and para. So here what is the nature of this carboxylic group? This is electron withdrawing group. Electron withdrawing group or ring deactivating group or electron withdrawing group. So this is a electron deactivating, electron withdrawing or ring deactivating group. So when there will be a ring deactivating group on the benzene, then electron density will be very less at ortho and para positions, at ortho and para position. So then when you do the electrophilic substitution, definitely it will attack at meta positions instead of ortho and para. Right? Normally, whenever there will be electron withdrawing group, normally this type of aromatic rings will not undergo Friedel-Crafts, acylation and alkylation. Like benzaldehyde also will not undergo. Okay, nitrobenzene also will not undergo. Okay, Friedel-Crafts, acylation and alkylation. Write down here. So here due to what? Due to ring deactivating group, deactivating group. What will get a ring deactivating group? There is no Friedel-Crafts reaction. Friedel-Crafts reaction. There is no Friedel-Crafts reaction. But you can get other reactions, not Friedel-Crafts reaction. Friedel-Crafts acylation, alkylation. Other than Friedel-Crafts, you can get the other electrophilic substitution reactions. What are other electrophilic substitution reactions? Right, let me give the examples. Like nitration. Nitration is what? HNO3 plus H2SO4. So you will get what? Where you will get nitration? At meta position. This meta position only will get substitution. You will get what? Meta-nitro-benzoic acid. Meta-nitro-benzoic acid is the product. Right now, in this nitration mixture, tell me which one is the acid and which one is the base. So we are mixing both are acids. In both acids, which one act as a acid, which one act as a base. So what is the main use of this nitration mixture? What is the main use of nitration mixture? This nitration mixture. Huh? What is the main use of this nitration mixture? So to get what? Nitro, to substitute nitro group on benzene ring. Only we are using this mixture. This is what nitration mixture. But what is the main use of this nitration mixture? Directly you can take HNO3. No. Why you are taking H2SO4? Amma? Neutralize. Both are acids only. If it is give OH minus, then what you will get? You will get electrophile. So to generate electrophile only we are taking H2SO4. Right? If you see that, so let me explain here. So HNO3, if you see that HNO3, this is what OH will be there. In sulfuric acid, HSO4 minus and H plus. Now this NO plus and OH minus. Now here in this acid mixture, HNO3 act as a base and this H2SO4 act as a acid. So here both are acid mixture, but in this among acid, whenever you are mixing two acids which is having more acidic strength, that is act as a acid and another one act as a base. So in this nitration mixture, H2SO4 act as a acid, it will release H plus ion, HNO3 act as a base. Then there will be a neutralization between these two. Resultant, what will get here products? You will get what? NO2 plus electrophile plus water plus HSO4 minus you will get. So now there will be a generation of electrophile. After getting this electrophile will substitute at meta position. So once it substitute at meta position, then so you need to remove H plus. Okay, this H plus will attack at HSO4 minus. Then again you can regenerate your H2SO4. So this is what use of H2SO4. Without H2SO4, you cannot do the nitration on the benzene ring. Okay, this is what nitration mixture. So when you do the nitration mixture, so here this is a base, this is a acid. So it is very, very important. Right. So you will get what? Meta substituted nitro product you will get. This is what meta substituted nitro product is the main product. So next, if you do the bromination means Br2 in presence of FeBr3. This is what Lewis acid. You can take Lewis acid like AlBr3 or FeBr3. Then you will get what? Bromination at meta position. You will get meta-bromo-benzoic acid. So next, if you want to do sulfonation, then what you have to take? You have to take oleum. Oleum is a mixture of SO3 and H2SO4. Here who is electrophile? This one is the electrophile. So then this electrophile will attach at a meta position. The resultant what you will get, Amma? You will get what? Meta sulfonyl group. This you will get it. what meta substituted sulfonyl group. So these are the products of electrophilic substitution on benzoic benzene ring. Okay, benzene ring at only meta substitution. This is what only meta. So due to this T activating nature, you will get the only meta products. So these are the main important reactions of chemical reactions of carboxylic acids. Okay, these are the main reactions. Right. Next, just 2 or 3 I will give some additional reactions which are important JE point of view. Some other reactions, let me discuss some other reactions or additional reactions. Other reactions or additional reactions, right? If you want to prepare amines from carboxylic acid, so you can use one reaction, that is what Schmidt reaction. Schmidt reaction. This is one name reaction. This reaction what is the main use of this reaction means it will convert carboxylic acids into primary amines. Right, if you see the reaction, this is carboxylic acid. When carboxylic acid treated with what? N3H. What is the name of N3H? In presence of strong acid like H2SO4. So here what is the name of this one? Hydrozoic acid. So this hydrozoic acid is acid, then it will get protonation on this resultant. What will get here? So finally you will get what? RCON3 will get it. This RCON3, then it will undergo loss of nitrogen, then finally you will get what? C double bond O and nitrogen and electron. This is a nitrene. Nitrene is what? Electrophile and electron deficient. When there will be electron deficient, then there will be a rearrangement of R group. So then what will you get here? So this R group converted into what? Shifted to nitrogen. Then you will get what? Double bond and carbon. This you will get it. After this, you have to do the acid hydrolysis. Okay, this is what acid hydrolysis. With that, what will get here? If you do the acid hydrolysis, then here H2 hydrogens will be added here, oxygen. Then you will get what? Primary amine plus carbon dioxide. So this is what preparation of primary amines from carboxylic acids. So reagent is what? In any reaction, if you have condition like this, this is what acidic hydrolysis, strong acid and acidic hydrolysis. This condition, whenever you have this condition, then directly you can convert carboxylic acid into RNH2. Carboxylic acid into RNH2. Okay, this is what preparation of primary amines, in that you can discuss. Okay, this is one extra reaction. Right, next, if you see the previously asked in JE based on this reaction. Right, next, uses. What are the uses of carboxylic acids? Give any uses, known uses. Amma? Vinegar. All right. Vinegar is what? Acetic acid. So you can use as vinegar. Next, right? You can take applications or uses of carboxylic acids. Right? Few carboxylic acids will be used. This year there is no, I think, polymer topic. This year in board point of view, I don't know in JE whether it will include or not. If you take carboxylic acids like phthalic acid, so when phthalic acid react, means when phthalic acid undergo polymerization with ethylene glycol, you will get what? Glyptol. Once asked in JE previous, okay, in exams, what is a glyptol? So uses, in this uses, glyptol is a one polymer which is used to prepare paints, okay, paints in paint industry, okay, like Asian paints, Nerolac paints, okay. So right, if you see the reaction, at what polymer, this is what? Glyptol. Glyptol is a polymer. Glyptol is a polymer of phthalic acid and ethylene glycol. So ethylene glycol. What is ethylene glycol? Ethylene glycol is a diol. So if you see the reaction, this is what phthalic acid. This is phthalic acid. When phthalic acid undergo polymerization with ethylene glycol. Ethylene glycol is what? CH2, and here OH and OH. If you take n number of this ethylene glycol and n number of this phthalic acid, then there will be a condensation. There will be a condensation. The resultant, what will you get here? You will get n number of, here this is what OCH2, CH2 and CH2. This is what glyptol. This is what glyptol. So glyptol, it is there in JE point of view. Right, glyptol is a polymer of phthalic acid and ethylene glycol. Ethylene glycol, it is a polymer. Next, other uses. Do you know nylon 66? What is nylon 66? Nylon 66 also polymer of what? Adipic acid and hexamine, hexamethylene diamine. So resultant you will get nylon 66. Nylon 66 is a one type of synthetic cloth. Okay, nylon 66 is a one type of synthetic cloth. So how you will prepare this? Nylon 66 means, so adipic acid. So adipic acid, what is adipic acid? CH2 COH. This is what adipic acid. When adipic acid undergo condensation with hexamethylene diamine. This is hexamethylene diamine. There are 6 methylene hexamethylene diamine, and this is adipic acid. Okay, adipic acid and hexamethylene diamine. If they undergo condensation, you have to take n number of this hexamethylene diamine and n number of this. Then there will be a condensation between this what hydrogen of NH2 and OH of COH group. Then you will get what? C double bond O and NH. You will get amide bond. There will be amide bond. So then there are n number of amide bonds. Resultant, you will get its corresponding polymer. So how will be the polymer? So polymer you can take it. So polymer is what? COOH, and here CH2 taken 4 times, and CO and NH, CH2 taken 6 times, and here NH. You can take it here. This is what? N number. These two are the chain propagation sites. This one and this one. They are chain propagate signs. Sign means what? They are sites. So with these sites we can elongate polymer chain. This is what nylon 66. So this dicarboxylic acid will be used for the making of nylon 66 cloth. This is what? Glyptol. So glyptol is a one type of paint. So this is a one type of nylon 66. What is the 6 means? 6 indicates what? The 6 indicates what? Carbon numbers. So here 6 indicates carbon number. In this there are 6 carbons. This carbon 1, carbon 2 and 4 carbons. 6 carbon. Here also 6 carbons. So always in the polymer. So 2, 4 means 2 carbon and 4 carbon. 2 monomers are combining, resultant you will get it. Nylon 6. Nylon 6 means only 6 carbon will undergo polymerization. Okay, like caproic acid. Next, nylon 66 means there are 2 monomers with 6 carbons. That is nylon 66. Okay. Here number indicates carbon number. Next, other uses. What are other uses? So you can take acetic acid as a vinegar. Okay, right. Next, vinegar. Okay. Next, sodium benzoate. Where you will use sodium benzoate? My girls, I need answer from girls. Sodium benzoate. Where you will use sodium benzoate? Huh? Where you will use sodium benzoate? The sodium benzoate you can use it as preservating agent. So whenever you are making, means after making pickles, okay, if you want to store long time, so you can use this sodium benzoate. Okay, sodium benzoate is a very good food preservating agent. Okay, right. This is what food preservative agent. So food preservative agent. Next, these are some important uses. Okay, this is what topic. So topic will be over. So now I will give some questions. We will discuss some questions. Write down questions. Write one question here. We have one reaction. So here we have one reaction. From this above reaction, which of the following compound cannot synthesize? Write down here. So if you want options, I will give options also. Write down. Right here question is we have Grignard reagent and carbon dioxide followed by hydrolysis, you are getting A product. So that what which of the following cannot be synthesized according to this reaction? So first option is formic acid, second option is acetic acid, and third option is benzoic acid, and fourth option is you can take any one cyclic carboxylic acid. So answer is first one, formic acid. You cannot prepare formic acid from the Grignard reagent followed by carbon dioxide. Why? Because in the Grignard reagent you need to have at least one carbon compound, at least methyl you have to take it. So to prepare this formic acid, so what you are taking here? Hydrogen. With hydrogen, if you put here hydrogen, you cannot get any Grignard reagent. It is meaningless. Okay. So when you take Grignard reagent treated with carbon dioxide followed by hydrolysis, you cannot prepare formic acid. Okay, formic acid you cannot prepare. So now answer is A, formic acid. Except the formic acid, you can prepare any type of carboxylic acid. Okay, I forgot to tell you that time. That's why I gave one question. Right, next, so I will give the one conversion. Just you have to give the final product. Okay, right. We have one compound which is react with magnesium and ether, dry ether. You are getting A products, and which is followed by carbon dioxide and acid hydrolysis. You are getting B products. So B is on heating with N3H followed by acid hydrolysis. You are getting C. So then what is the C? Come. So answer is right. Answer is aniline. So answer is here C is what? Aniline. Right here you will get what? RMGX. This is what pH. You can take it pH. So here you will get what? pH, Mg, Br you will get phenyl magnesium bromide RMGX preparation. After getting RMGX, it reacts with CO2. Then you will get what? Benzoic acid. This is what? Benzoic acid. So this is what? Schmidt reaction. Then there will be a conversion of COH into NH2. Then you will get what? Aniline. Aniline is the final product in this reaction. This is what? Reaction conversion. Okay. Let me link with other functional groups. Right, CH3 CO CH2 COH. On heating you will get A products. Then after this I2 and this you will get what, E plus C. So both are reducing with lithium aluminum hydride. You will get D and F followed by hydrolysis. Right, what are D and F? Okay. What are D and F? Ma? Right, right. Methanol and what? So what are D and F? Final D and F. What are D and F? Huh? Methane. Methane and ethanol. Ethanol is correct. Acetic acid. Methane. Methane and ethanol. How you are thinking methane? How you are getting methane? Explain. Huh? Huh? Yes, iodoform and you will get ethanoic acid. Okay. Right here, firstly, what you will get here? Ketone you will get, ketone. Acetone is the product here. Right, this is what iodoform reaction. When you do the iodoform reaction, so here one of CH3 converted into what? Iodoform CHI3 and another converted into what? Acetate. Acetate on hydrolysis you will get acetic acid. When you do the reduction with lithium aluminum hydride, you will get what? Ethyl alcohol. Ethyl alcohol. But here with iodoform there is no reaction. There is no reaction. Just what to make you confused, I gave F product. So here there is no reaction. Just you will get only this D product, that is ethyl alcohol. So iodoform is the solid form. Iodoform is the solid form. Then you can separate. So when you treated this mixture with lithium aluminum hydride, only acetic acid converted into ethanol, but not this. This solid you can separate from this liquid. Okay. No reaction. You have to say no reaction. Okay. There is no F. Either D is ethanol means F is nothing. F is ethanol means D is nothing. Okay. So right, this is what one conversion. Right, next. Right, let me take one stereo reaction. So here we have COH and this is what CH3, and here this is ethyl, this is what H. So when treated with SO2, SOCl2, this is one condition. Next, second, diazomethane. Third one is moisture, this Ag2O. So here my question is, with stereochemistry how to give it? Whether so what is the product A? So we have asymmetric center. With respect to asymmetric center, is there any change or not? You know the reaction. It is there in alkyl halide topic and alcohol also. So what is the product A? So what is the product? In the product, stereochemistry will be retain or maybe inverse or racemic mixture. So what would be the product? Is it retained product or inversion product or racemic mixture? Which one, Amma? I think you have one SNI reaction. Do you know SNI reaction in alkyl halide topic? Don't know? No? Yeah. Then it's very difficult. SNI means internal nucleophilic substitution. So when there will be an internal nucleophilic substitution, then you will get what? Retained configuration. So product is what? Retained configuration. When there will be a SNI mechanism. So whenever you use this SOCl2, mechanism is retention of product. So with alcohol you have, I think, reaction, SNI reaction, alcohols convert into alkyl halides. Alcohol convert into alkyl halides. Okay. The next with SN1, with pyridine and without pyridine. We have reaction with pyridine and without pyridine. With pyridine, so normally what will get? You will get SN2 reaction. Without pyridine you will get what? SNI. SNI you will get it. Same way here also, when you use SOCl2, also SNI type of mechanism. That means, so here whatever this SOCl2 react with what? COH group, it will block. Block means there will be a chlorination. So here there will be a chlorination, means you will get product CO, Cl is the product with respect to this one. So after followed by hydrolysis, then so from this reaction what you have to do? You have to insert this CH2 between COOH and this carbon. So whatever configuration is there, as it is you have to write it. Whenever you use SOCl2, it is a retention of product. So it is a retention of product. So it is a retention of product. It will give the what? Retention. Retention means as it is. If it is R configuration, in the product also you have to get R configuration. If it is S configuration in the reactant, and the product also will be S configuration. Why? Because so here reaction will take place from the same side, not opposite side, same side. When it is takes place same side, then so product will be retention product means. So what is the product here? I thought you know. This is what? CH2 and COOH, and this is what? H. So always you need to remember one thing, whenever you are using SOCl2 as a reagent, so product is what? Retention. Why? Because so it will react with the same side, okay. So this is what I thought you know in alkyl halide topic, in substitution, nucleophilic substitution reactions, it is there. Okay. With stereochemistry you can think. Right, next one more conversion. Right, this question asked, I think, in previous JEE, a simple question, I think so. Which of the following carboxylic acid easily will undergo decarboxylation. Right. Which of the following will undergo easily decarboxylation? So I will give some products, some reactants of carboxylic acids. This is COH. Next, COH. This is what double bond O. And next, right, among three, which one easily will undergo decarboxylation? So there are three. So all are beta keto carboxylic acids. In first example, only one keto group. In second example, there are two keto groups. In third example, there are three keto groups. So which one easily will undergo decarboxylation among three given examples? So tell me which one will undergo easily. In 1, 2, 3. You can take it 1, 2, 3. In 1, 2, 3, which one will undergo easily? Girl side, boys. Amma? Third, why third? Just you think it, just try to apply basic things. Yes, you are right. So third will easily undergo decarboxylation. But reason? What reason you are going to give? Amma? 2 alpha. So here also 2 alpha, no? Here also 2 alpha. This won't affect no third one, with that no connection with this. No connection. Right, actually here this is what alpha and beta. This one also here alpha and beta. Sorry. This is alpha. This is beta keto. This is alpha and beta keto. This is what alpha and beta keto. Here also alpha and beta keto. Here also alpha and beta keto. There are 2 keto. Here there are also 2 keto. But one more C double bond O is there. Right. So if you see that, so after decarboxylation, then if you see that after decarboxylation, what will get Amma here product? You will get what? This double bond O. This is a keto form. So then due to tautomerization, so it will undergo tautomerization also. You will get enol form also. But here getting enol form is very less. Okay, this is what carbonyl compounds will undergo keto enol tautomerization. So here also if you write the enol form, this is what enol form of this first compound. Same way here after decarboxylation, here also what you will get here with respect to this one also you will get what? Firstly let me write double bond O and here double bond O. If it is undergo tautomerization, so what you will get here? This is what OH double bond and this is what here conjugated double bond you will get it. Next from the third one, after decarboxylation, what you will get here? This is what double bond O and double bond O. This is what symmetrical triketone. So if it is undergo keto total enomerization, then what you will get here? All 3 double bonds converted into OH groups. That means what you got final product in third case? Aromatic compound. Getting aromatic compound. So here getting aromatic compound is always stable, more stable than any other thing. So that's why here this third compound, once it loses carbon dioxide, then so you will get what? Keto from this enol form converted into keto form converted into enol form. So this enol form is 100% stable. Why? Because due to its aromatic character. After decarboxylation, in this you are getting aromatic nature. So getting always aromatic nature is highly stable than any other intermediate or any other compound. So that's why rate of reaction is what like this. Rate of decarboxylation reaction order is 3 is more than 2 then 1. This is what aromatic character. So finally you are getting aromatic character. Due to getting aromatic character, so third easily will undergo decarboxylation. Okay, this is what you can give it. So in NCERT we have very simple reactions. Okay, not more than. In NCERT we have very simple conversions, not any stereochemistry and not JE point of view, just only NEET and up to JE. Now this NTA, when NTA started conducting exams, so they are giving very simple JE mains paper, purely from NCERT only. If you are thorough with NCERT, happily and easily you will crack NEET as well as JE. But if you want to get good score, so 99.99 means, so you need to do advanced level. In NEET, if you want to score above 390 or 700, so you need to prepare standard of JE. Who are preparing NEET? Right, this is what carboxylic acid. Okay. What am I? What's the time now? Let's. Time is there now. I'll give the NCERT conversions. Just so NEET point of view, NCERT practicing NCERT is very important. Just 2 or 3 NCERT problems we will solve it. Where I have NCERT text. What do one NCERT problem, 1 or 2? Nothing, so easily you will get, I think so. Right, here one conversion. If I do one conversion, 3-nitrobromobenzoic acid, so you need to convert conversion 3-bromo, 3-nitro or bromo, right, 3-nitrobromobenzene, sorry, 3-nitrobromobenzoin, converted into 3-nitrobenzoic acid, benzoic acid. How you will convert 3-nitrobenzoic acid, 3-nitrobromobenzene converted into 3-nitrobenzoic acid. How you will convert? Just Grignard reagent, carbon dioxide followed by hydrolysis. That's it. Right. If you see the reaction, firstly you need to write the structure of this compound. Here given compound is what? Here 3-nitro. This is what 3-nitrobromobenzene. Here this is what 3-nitro. No, sorry. This is what 3-nitro 1, 2, 3, 3 nitrobromobenzene. So when this reagent means you need to introduce benzoic acid, means here what is the difference here? There will be a COH group. So to introduce COH, firstly you need to prepare Grignard reagent. This you have to convert into Grignard reagent. To convert into Grignard reagent means this whole group is what R and this is X halogen. So when RX reacted with magnesium powder in presence of dry ether, then what will get here? There will be insertion of magnesium between bromine and this alkyl group. So resultant what will get here? This is what here magnesium and bromine, and this is what 3 nitro. You will get this is R MgX. Then if you give carbon dioxide followed by hydrolysis, acid hydrolysis, then this is what minus, this is a plus. This minus will attack at carbon dioxide. Then you will get what benzoic acid, and here nitro group as it is at third position. So now this product is what 3 nitro benzoic acid. This is what simple conversion. Butanol to butanoic acid, exemplar question 12.5. So also very easy, you can convert it. 1 butanol to butanoic acid, benzyl alcohol to phenyl ethanoic acid. Right, this you can do it conversion. How you will convert this benzyl alcohol into phenyl ethanoic acid? Benzyl alcohol into phenyl ethanoic acid. Do next one more conversion. Amma, right. Cyanide. You need to introduce cyanide group followed by hydrolysis. Then you will get one extra carbon. Very simple reactions only, not much. NEET point of view and JEE mains point of view, you can expect direct questions from organic, inorganic and physical as well as, but only JEE advanced point of only there are twisting questions. Okay. Right, this is what carboxylic acids. This is our last class. Right, thank you.